Hello everyone, this is your tutor AB. Today we're going to be solving a problem from the May 2023 IB Mathematics AAHL examinations. This is a paper 1 question of 7 marks. Let's get started. Use mathematical induction to prove that the summation of r over r plus 1 factorial starting from 1 to n is equal to 1 minus 1 over n plus 1 factorial for all integers greater than or equal to 1. Okay, so to start off a mathematical induction problem, we always want to prove the base scenario where n is equal to 1. So that's our piece of 1. N is equal to 1. Let's see if this is true. So we simply substitute 1 into left hand and right side of the equation and see if they're equal. So 1 over 1 plus 1 factorial is it equal to 1 minus 1 over 1 plus 1 factorial? Well, 1 over 2 is equal to 1 minus 1 over 2. So I simply get 1 over 2 is equal to 1 over 2. So piece of 1 is true. Proven. Okay. So then we go to our piece of k. So as piece of 1 is true, so we simply say assuming piece of 1 is true whenever piece of k is true. This is our second case. We are assuming that piece of k is true whenever piece of 1 is true. So we can put our second step to the mathematical induction where we substitute k for n. So let's do that. So let's start from 1. 1 over 2 factorial plus 2 over 3 factorial plus 3 over 4 factorial all the way till k over k plus 1 factorial. And that is equal to 1 minus 1 over k plus 1 factorial. This is our piece of k. So now we're at piece of k plus 1. This is our last and final step, which is also the toughest step. What do we do here? Here we're supposed to substitute n is equal to k plus 1. Okay. So how shall we approach this problem? Well, we'll simply be left with 1 over 2 factorial plus 2 over 3 factorial plus 3 over 4 factorial all the way to k over k plus 1 factorial plus the next term of this k plus 1 factorial or k plus 1 over k plus 2 factorial. And that must be equal to 1 minus 1 over, and instead of k plus 1 it will now be k plus 2 factorial. How do we approach this? Well, we know this whole section right here from our piece of k step is just equal to 1 minus 1 over k plus 1. So we'll substitute 1 over 1 minus k plus 1 instead of this. So you get 1 minus 1 over k plus 1 whole factorial plus k over k plus 2 factorial, k plus 1 over k plus 2 factorial is equal to 1 minus 1 over k plus 2 factorial. Now I'm simply going to only manipulate the left side. I'm not going to touch the right side. Let's create a common denominator. Firstly for these two. Okay, so I'll be left with k plus 1 factorial minus 1 all over k plus 1 factorial. So and that's equal to 1 minus 1 over k plus 2 factorial. Okay, what's the next step? Let's again create another common denominator between these two fractions. What do I need to multiply into k plus 1 factorial to get k plus 2 factorial? Well, just k plus 2. If I multiply k plus 1 factorial times k plus 2, I'll get k plus 2 factorial on the bottom. So that's what I'm going to do. So I'll get on the numerator k plus 2 times by k plus 1 factorial minus 1 times k plus 2. And this whole thing over k plus 2 times by k plus 1 factorial plus k plus 1 over k plus 2 factorial, and that must be equal to this right side. Okay, again, I'm not going to touch the right side. I'm going to continue with the left. As I said before, k plus 2 times by k plus 1 factorial is k plus 2 factorial, because if we say 2 factorial times by 3, that just becomes 3 factorial, doesn't it? So same logic applies here. So k plus 2 into k plus 1 factorial becomes k plus 2 factorial on the top minus k minus 2 plus k plus 1 all over k plus 2 factorial, and that must be equal to 1 minus 1 over k plus 2 factorial. Okay, what's our next step? Let's simplify this further. K and k will cancel, so I'll be left with k plus 2 factorial minus 1 over k plus 2 factorial. Now, can I split this fraction to look like the right side? Well, yes, I can. Simply it will become k plus 2 factorial over k plus 2 factorial minus 1 over k plus 2 factorial, and that must be equal to 1 minus 1 over k plus 2 factorial. Now simplifying this further, you simply get 1 minus 1 over k plus 2 factorial is equal to 1 minus 1 over k plus 2 factorial, and hence you've proven the mathematical induction.